With the sexual propagation of plants from seed, one of the main characteristics is the germination of those seeds and the considerations that affect that rate of germination. So when you look at a seed, the main thing that's either inhibiting the germination of that seed is either inhibiting chemical factors within the seed itself, or the seed coat that prevents the growth of the radicle and the plumule, which will start the growth of the young plant. So the inhibiting of the growth of the seed is due to the survival adaptation that the seed will survive prolonged periods of unfavorable environmental conditions, and then there has to be some way of switching on the germination of that seed when the more favorable environmental conditions are encountered. So that generally is when there's good moisture and there's good warmth within the environment, where the young plant has the greatest success of growth within that environment. So the inhibitors, the seed coat and the chemical inhibitors with the seed are designed to stop the growth of the seed when those more ideal germination conditions aren't present. So they can be overcome by either abrasion of the seed coat. So if that's the main inhibition, like a lot of tree seeds are, you can overcome that by some sort of abrasion of that seed coat. So you can scarify it, you can scratch it, you can chip it, you can make some weakening of that. So you can soak it in a weak acid, or you can boil it gently, or you can soften it by scratching or chipping it. The other one is the chemical inhibitors that are most reactive to changes in humidity or temperature within the environment. And they can, sometimes they need to be overcome by a period of freezing. So if it's a tree seed, for example, that comes from some temperate region where there's quite a cold winter, often you need to replicate those conditions by putting it in the freezer for 2 or 3 months to be able to overcome those chemical inhibitors. And then when you take it out of the freezer and you warm it up and you provide it with a moist environment, the chemical inhibitors will break down, and the storage of nutrient molecules and enzymes within the seed will be activated, and that will initiate the growth of the plumule and the radicle from the embryo. So the plumule is the baby, the first leaves of the tree. So as it grows and extends up through the soil, the cotyledon, which is the main source of energy for the growth of seed, first emerge, and they can start photosynthesizing to a certain extent, and then the radicle, as it grows, starts to grow the first true leaves, and they're the ones that function as a normal leaf does, that will photosynthesize more effectively and start the flow of sugars and saps through the plant to support the growth of roots, which is the radicle, which will be drawing the water and the minerals up out of the ground. There's so the cotyledon's like a store of energy within the seed, and it can either be a dicotyledon, which is generally veined, leafed, flowering plants with normally 5 or 6 petaled flowers. So most of our flowering shrubs and trees and vegetables are all dicotyledons. Or it could be a monocotyledon, which have more straight leaves with parallel veins, and generally just a 3-petaled flower, and they're more like the grasses or corn or maize. So the germination, overcoming the germination effectively is normally the main consideration with the mass propagation and the efficient production of a plant using sexual propagation.